Hello, greetings to you all. Welcome to grade 8 tutor. Today we are going to look at integration under quantitative methods. And so in our previous lesson, we looked at differentiation, and we are just going to do the reverse of whatever that we have done already. And so under differentiation, we realize if you have 2x exponent 2, what we do is we multiply this 2 by the exponent here to get what? 4 x, then you reduce the exponent by 1. So you have 2 minus 1. So your final answer will be 4x exponent 1, or you can say 4x. So that is what we did under differentiation. Okay, but this time around we are just going to do the reverse of whatever that we have learned. And so this we have 4x. Okay, so 4x, we are going to integrate this. So if you integrate this, you have to get this, right, plus a constant. So that constant can take a form of any number. Do you get that? Okay, so with this form, if it were to be under differentiation, you would have used the exponent to multiply this, right? But this time around, you are going to add 1 to the exponent instead of reducing it. So you have 1 here already. You add 1 to it. You get it? Then you divide everything by the exponent, which is 1 plus 1. So you have 4x exponent 2 divided by what? 2. So if you see this 2 goes into this forward 2 times. So you have 2x squared, right? So this is what? The integration. So if you differentiate this, you get the 4x, which is here. So if you integrate the 4x, you have to get what? The 2x exponent 2. Okay, so let's look at the format and how it works. That is what we are going to do. We are just going to do the reverse of whatever that you have learned. And it's very short and simple as well. Okay, so there's the format. Y is equal to integral value of, suppose you have n, you have x exponent n. Let's say you have a function like this, dx. Okay, so this is the differentiated or the differentiate of the function. So this is the integral value. Now, if you want to integrate this, already it has to be in a form of dy dx because you have differentiated it. So if you want to integrate it, you are bringing it back to y. You see that initially it was y equals to a certain function. Then we differentiated it to get dy dx. So now if you want to integrate it to get y, this is the procedure that you have to go through. And so this is what we do. The x is when you eliminate this. Immediately you write the y. This one will go off, the integral value. This one will go off. So now you have what? X exponent n. So you have x exponent n. Right? Let me write it big. So now you have y equals what? X exponent what? N plus 1. Okay. Then you divide everything here by the exponent, which is n plus 1. You are done. So because it is integration, always you have to introduce what? A constant value, that is k. So this k can take any number. You see, sometimes when you are integrating and you have, for example, you have y equals 2x squared plus 3. When you are differentiating it, you write dy dx equal to, this one will give you 4x plus, because there is a constant term, it becomes 0, right? So you see that your differentiation becomes what? 4x without what? The constant term. So when you are integrating this again, what you have to do is you integrate it by saying y equals, now you add 1 to the exponent to get what? 4x1 plus 1. Then you divide here by 1 plus 1. Do you get it? Because you are bringing it back, you don't know the constant because they differentiated a certain constant to get 0. But because you have been given the differentiation, you don't know the constant. So you have to introduce what? K to represent that constant they differentiated to get 0. That is why we always introduce what? The k here. And so this one becomes what? The integration of this. So always you have to introduce what? K. After integrating it, you introduce K to represent what? The constant. Okay. So that is what we are going to look at today. Let's pick some questions and we'll go through them to see how it works. Okay. So find the integral value of, so let's say, sorry, find y if you have the y dx, because integral value of 3 dx. Okay, so you are to integrate this. Now if you want to integrate this, it's very simple. This is the y dx, right? Initially it was y and now it is the y dx. So when you are sending it back, you just have to write y, okay, because you are bringing it back. Okay, equal to, now because we have written y, the integral value is gone. Okay, 3. So you have this. Okay, don't forget I said any constant term in our previous lesson and the differentiation. I said any constant term has x exponent 0 attached to it. And x exponent 0 is 1. So 4 times 1 is 4. That is why normally you see 4. We eliminate this. But every 4 or every constant term has what? X exponent 0. So it means this 3 has what? X exponent 0. It has x exponent 0. So we add 1 to the exponent and we divide everything by what? The exponent 0 plus 1. So you have y equals 3x exponent 1. Right? 0 plus 1 is 1 over 1. And so y equals to 3x, because 3x exponent y is the same as 3x. And any number divided by 1 is what? The number itself. And so we have what? 3x. Sorry, I didn't introduce my k. So now your y is equal to 3x plus what? K. Okay. So that is just the differentiation. And another question, evaluate this, dy dx equals to, uh, you can be given it straightforward without dy dx. So anytime you see integral value, it means integrate it. Do you get it? Anytime you see integral value, it means integrate the function that is given. And so let's say you have 8x exponent 3 dx and you have been asked to evaluate. Okay, so the same procedure. What do? We write our y equals to 8x exponent 3, right? Then we add 1 to the exponent and we divide everything by the exponent. Then we bring our k, that is the constant term. Don't forget the constant term. Okay, so y equals to 8x exponent what? 4 divided by 4. So this 4 can go into what? This 8, what? 2 times. So you have 2x exponent 4. This one goes here 1. Goes here 2. So you have 2x exponent 4. Right. Yeah, 2x exponent 4 divided by 1 plus k plus k. Okay. So your final answer is y is equal to 2x exponent 4 plus k. This is the final answer. And so that is the integration we are talking about. So let's move on and solve one complex question. Then we do a little application on question. Then we are done with integration. So we are to solve 3x squared plus 2x plus 1. We are to solve this dx. Okay, so we are to evaluate. We are to evaluate integral value of 3x squared plus 2x plus 1 dx. So you can pause the video and you try it yourself. Okay, so this is sum, right? So you are going to do it separately. So this one You integrate this, you integrate this, you integrate this. Right? That is very simple. Okay, so try it yourself and provide the answer at the comment section, and I'll just come there to verify it for you. Okay. So if you don't understand anything, to you let me know, or you can just text me. I'll make sure I send the answer to you. Okay. So let's move on to the application. Let's move on to the application. The application. Okay. So for the application, just like we did in the previous lesson, we have what? Total cost. We have total cost. Total cost. We have total revenue. We have marginal cost. We have marginal revenue and our profits. Marginal revenue. We have profits, that is total profits. Then we have marginal profits. Marginal profits. So it's just like what we did in the previous lesson. So anytime you see in the previous lesson, anytime they give you total cost, they ask you to differentiate it to get what? Marginal cost. In this case, all the parameters that are going to be given to you, they are in the form of what? Marginal cost, marginal revenue, marginal profit, and all that. So you have to what? Integrate it to get what? The total cost, the total revenue, and the total profits. You get it? So you just follow the same procedure. Okay. So I'll give you a question here. So let me help you solve this one first. So I'll just give you a question under the application. So let me solve this one myself, and you solve this one. Okay, so let's integrate this. We have y equals 6. Sorry. We have y equals 3x exponent what? 2 plus 1 divided by 2 plus 1. That is the first one. Then we move on to the second one, which is 2x. You see this one has exponent 1, right? So 1 plus 1 over 1 plus 1. Then we say plus. This constant here, the one here, has x exponent 0 attached to it. So don't forget. So you have 1 x exponent 0 plus 1 over 0 plus 1. Then you don't forget to introduce your k. Okay? Don't forget to introduce your k. So that is it. Then we simplify them. This is what? 3x exponent 3 over 3 plus you have 2x exponent 2 over what? 2. Then you have plus 1x is the same as what? 1. Okay. So 1x is the same as 1x is the same as x, because any number multiplied by 1 is the number itself. So you have x exponent 0 plus 1 is what? 1 over 0 plus 1 is 1 plus k. Okay, so this is the simplification. So let's proceed. You have y equals, this 3 can cancel out this, so you have this. You are left with what? X cubed. This can also cancel out this, so you are left with what? X squared and plus. So x exponent 1 is x. X divided by 1 is x. So we write our x plus what? K. So this is our final answer. This is our final answer. This is our final answer. Okay, so now since we are done with this is very simple. It's just like the previous one. So just integrate it, reverse it, just like this. Instead of reducing the exponent, now you are adding the exponent and you divide the whole function by what? The exponent. You get it? Yeah. So you see here we had the exponent 3, and that is what? The denominator. Exponent 2, that is the denominator. Exponent 1, that is the denominator. You get it? So that is how it works under integration. So let's tackle one question under the application. Then I'll give you some 1 or 2 questions to try. Okay. So here we have, it says the marginal revenue in dollars per unit for a motherboard is, you have MR equals 300 minus 0.2x, and it says where x represents what? The quantity sold. So the quantity is what? X. Okay. Find the I, revenue function. So you have to find the what? Revenue function. And II, you have to find total revenue from the sale of total revenue. Right? So total revenue from the sale of total revenue from the sale of 1,000 motherboards. 1,000 motherboards. Okay, so that is it. Let's see how to calculate for this. Okay, so the first question, it says we have to calculate for what? Or we have to solve for the revenue function. Do you get it? Yesterday, or in our previous lesson, we realized the revenue function is always given, and you'll be asked to calculate for what? The marginal revenue. Do you get it? But in today's lesson, marginal revenue has been given, and you are to integrate the marginal revenue to get what? The revenue. Do you get it? And since you have the marginal revenue function, what you have to do is you have to integrate the marginal revenue function to get what? The revenue function. Do you get that? Okay, so it's very simple. You know how to integrate a function like this. So we say I revenue function. So revenue function. So with this revenue function, we write our marginal revenue equals 300 minus 0.2x. Okay, 0.2x. And so we are going to integrate it. When you integrate it, you get revenue, not marginal revenue. So you get revenue. So here would be what? 300. There is x exponent 0 attached to it. So we write x. Let me write it big. So we have revenue equals what? 300 x exponent 0, right? Then we add 1 to the exponent. The x exponent 0 is attached to it already, and you know it's under differentiation. So we divide it by 0 plus 1. Then you move on to the next function, that is 0.2x, and x has exponent what? 1 already. We add 1 to it and divide the whole thing by 1 plus 1. Then we bring our constants. Okay, now let's proceed. We have r of x, that is the revenue function, 300x, because 0 plus 1 is 1. X exponent 1 is what? X. Then you divide it by what? 1. And it will give you what? Okay, so I'll do that in the next step. So here too you have what? 0.2x exponent 2 over 2 plus k. And so the revenue function is equal to 300 what? X. You have 300x here minus this 2 will go here with 0.1. Is that okay? So 0.1 x squared plus k. So this is the revenue function. This is the revenue function. Okay. Oh, sorry. This is not the revenue function. Since we have k in it, we have to do something to it to get the revenue function. You get it? So we are going to get the revenue function in the next step. Do you get that? And so anytime you have k in the function, it means you are not done. There is something that has to be done before you get what? the revenue function. And what is that? We know the quantity is what? X. We know the quantity is X. And the question did not tell us anything about the quantity, as in this is the number of quantity they sold. I hope you get that. That is in the next question. But before you derive the revenue function, the question, that preamble, has to provide you the number of quantities sold or the amount of a particular revenue, so that you can substitute it to get what? Your key. I hope you get that. So since there was no quantity, it means there was no revenue. I hope you get that. Because they didn't give us any value of what? X. So if no quantity is sold, it means we don't have any what? Revenue. So when X equals 0, we say our revenue is also equal to what? 0. Because if you don't sell, how are you going to earn? You are not going to earn. So your revenue is what? 0, and your X is also what? 0. So you have what? 300 300x, right? So the x is 0 minus 0.10 squared plus k. So everything here is 0, here is also what? 0. So you have k equal to what? 0. So now you are going to substitute what? The value of k into this function. And if you get, or if you substitute the value of k into the function, you are done for the revenue function. Okay, so now you know k is 0. So if k is 0, then it means the remaining function becomes what? The revenue function. So we say our r of x, or the revenue function, is equal to this. That is 300x minus 0.1 x squared. It is plus 0, but plus 0, there is no need for us to provide it. So this is our revenue function. This is our revenue function. It's very simple. It's very simple. Let's proceed to the next question. It says we should calculate for the total revenue from the sale of 1,000 motherboards. So it is now that they have made what? Sales. So since there is a sale here, it means we have to substitute what? This 1,000, because they sold what? 1,000 quantity of motherboards. So you can now substitute this 1,000 into the revenue function to get the total revenue they are looking for. Okay, this case is, it shouldn't be here. Okay, so you are to substitute what? This quantity into the revenue function to get what? The total revenue. And so let's find for the total revenue. The total revenue here. So it is 1,000, right? 1,000 motherboards. So 300 times 1,000. You have 300 times 1,000 minus no space. So what do I do? Okay, now we know the quantity is what? 1,000. So let me write it here. The revenue R of 1,000. We are substituting x equals what? 1,000. So it's equal to 300 1,000 minus 0.1 1,000 squared. So this is the function, and we are done with the substitution. So you have, if you make 1,000 sales, you are going to get, this is what? 300,000 minus this. And if you perform, or if you do these calculations, you are going to get 200,000. You are going to get 200,000. So what's the amount in cedis or dollars? So that is dollars. So that is $200,000. Okay. So that is it. This is the total revenue. The total revenue is $200,000. So this is how we solve the application of integration. This is the application of integration. First of all, let's run through the test again before we attempt the second question, and we say bye-bye to integration. So let's go over again. The question said there is the marginal revenue function, and the quantity is x, and we are to calculate for, or we are to solve for the revenue function. and also the total revenue from the sale of what? 1,000 motherboards. Note one thing here. From the first question, find the revenue function. If the question proceeds to tell you find the revenue function if the number of units sold were, let's say, 1,000 units and the revenue is $500, you can substitute it to find what your K. Do you get that? But since there is nothing like that here, you have to bring what? Zero as your quantity, and your revenue also becomes zero. So at this point, your K will also what? Zero. So it is after you have gotten the revenue function that the company made what? Sales. That is why we substituted what? The 1,000 into the function. And so if you read from here, you see that from the revenue function, we have the marginal revenue and we integrated what? This to get what? The revenue function. That is this. Yeah, we came to this part of the calculation by integrating it. You know how to integrate it to get what? This particular function. And here you have to eliminate what? This key. You get it? But you don't know the value of k. Before you eliminate this k, you have to know x and the revenue. So if the question does not provide you with what the revenue and the value of x, it means just put what? Zero there. And automatically k becomes what? Zero. Okay. Then if k is zero, you construct the revenue function like this because k is zero and there is no need for us to write it zero. And so this is the revenue function. So when you are done with the revenue function, you come to what? The second question. You are to find the total revenue. Now the total revenue from the sale of what? 1,000 motherboards. And so 1,000, it means quantity. They sold what? 1,000. So you are to substitute 1,000 with what? X. So that is R of what? 1,000 instead of R of X. So wherever you see X, you put what? 1,000. And now the total revenue is what? $200,000. Let's tackle the second question and we are done. Okay. So we are going to go through the same procedures again. Whilst I'm solving it, you can pause the video and also try it yourself. Okay. So the second question. Okay. So there's the second question. It says, suppose the marginal cost function for a month for a certain product is, so the marginal cost is what? We say MC equals, we have 3Q minus, plus 50. So that is the marginal cost. Where Q is the number of units and the cost in what? Cedis. So Q is the number of units. So the Q you see in the function is what? The quantity. So the quantity is equal to the Q. And the cost is in what? Cedis. So we have to know our, in monetary terms, we have to represent it by what? Cedis. If the fixed cost related to the product amounts to what? 100 Ghana cedis per month. So we have what? Fixed cost. We have fixed cost. And that is what? 100 Ghana cedis per month. So we have 100 Ghana cedis per month. Okay. Find the total cost function for the month. So this one we have to calculate for just the total cost function for the month. I hope you get that. And so that is very simple. This one we are not supposed to calculate anything else. And so this is the solution. We have marginal cost. So we have to find the total cost function. What do? We integrate it. And so we say MC equals 3Q plus 50. So if you integrate it, you get C of Q. Don't forget that variable here is Q. It is not X. So you don't have to write X here. Okay. So you are differentiating, or you are integrating it with respect to what? Q, not X. And they differentiated it to get this with respect to Q, not X. So this one we have what? 3q. We have exponent 1 here already. So 1 plus 1 over 1 plus 1. We have plus 50. So 50 has x exponent 0 attached to it. We add our 1 and we divide it by the exponent. Then we bring our k. Okay. So c of q is equal to, we have 3q. Exponent 1 plus 1 is what? 2 divided by 2. Okay. Plus, then we have what? 5. Sorry, we have 50x over 1 plus what? K. Okay. So we say the, okay, we have k here, so we are not done. We have c of q is equal to 3 on 2 q squared plus 50. Is that supposed to be q? Yeah. Sorry, forgive me. Yeah, q. Okay. So 50q plus what? K. There is one last thing to be done before we get our cost, because there is k here, and whenever you have k in the function, it means you are not done with the function. There is something that has to be done. And so what do we have to do next? Look at the question. We were given what? The fixed cost. And the fixed cost is what? The total cost, which is here. Do you get it? But we were not given any quantity. And so if we were not given any quantity, and we know the fixed cost to be 100, it means the cost is what? 100, and the quantity is 0. So 100 is equal to 3 on 2, 0 squared plus 50, 0 plus k. So this is 0, this is 0. So 100 is equal to k. So we can say, therefore, your k is equal to what? 100. I hope you are okay with it. Yes. So that is why I said, from the question, if they give you what? Fixed cost or total revenue, and they give you the quantity, you substitute. If they give you fixed cost without the quantity, it means the quantity is 0. If they give you the quantity without, okay, it doesn't normally happen whereby they will give you the quantity without the cost. Do you get it? Because we incur cost to produce quantity. Do you get it? So anytime you are giving, let's say, revenue without quantity, you replace the revenue or the quantity by what? 0. Then if you have fixed cost without the quantity, you replace the quantity by what? 0. Situation whereby you have both, you replace it, you replace the fixed cost by the value and the quantity by the number of units given, just like that. So here we were not given any quantity, that is why it is what? 0. And so now our cost function becomes, we are bringing k, which is 100 here. So we say our c of q is equal to 3 on 2 q squared plus 50q plus 100. That is k. So we are done. That is our cost function. That is our cost function. So I'm giving you 2 examples to try your hands on them. Then we say bye bye to integration.